everyone. On today's webinar, I would like to talk about Amazon Bedrock knowledge bases and how can you build retrieval augmented generation systems on AWS in 2025. I would like to start with a quick introduction of myself. So I'm Kacper Włodarczyk. I work at Chaos Gears and I'm AI engineer. Before, I was also working as a machine learning developer at Web Developer. And if anyone wants to get in touch, here's my LinkedIn URL. So you can just contact me right there. Regarding Chaos Gears, so the company I work in, we are official certified partner of AWS at the advanced level. And we specialize in cloud migration, cybersecurity, and of course, data and artificial intelligence. We are a partner of Passus Group, which is listed on Warsaw Stock Exchange. And we are the first company in our region, so Central Eastern Europe, to achieve AWS Generative AI competency. And regarding the agenda on today's meeting, I would like to start with a very quick introduction to generative AI and retrieval augmented generation. Probably you are already familiar with that, but just in case. And then very quick overview of Amazon Bedrock, what it offers, what is it. And then the main part, so demo, how to build retrieval augmented generation on Amazon Bedrock. And the last part will be some lessons learned or rather tips how to build such system optimally. Okay, so let's begin. So let's begin with Intro to Generative AI. And actually, I would like to start with explaining what are the differences between like traditional AI and this new wave, which is generative AI. So first thing that is a feature of traditional AI and maybe some limitation is that those models are specialized. So let's say that you want to build a pet classifier. So first you need to gather some data set with annotations, and you also need to have some algorithm that you can train on this data set, right? And those ingredients can be then placed on some compute environment where you can run some training script, and this will produce a pet classifier in our case, right? And then in production environment, you can apply images on this pet classifier, and the classifier will tell you what type of a pet is on the image. And the second thing I would like to note is that those models needs retraining to adapt to new use cases. So let's say that now you want to apply a classifier on a different use case. Let it be car classification. So what car is on the image? So then you need to basically do once again the whole process of training. So you have this data set and you need to get some algorithm. You can actually use even already trained algorithm like this pet classifier, as it already learned some feature extraction from the image. So you can reuse it for new use case. And you put it on some compute environment once again, and you training it, and the result is another classifier. This time it's car classifier, so you can use it to classify whether, for example, the car is a hatchback or SUV or anything else. So at any time there is like a new class in your data set, or you want to use it on new data set, you need to retrain it basically. And then, so what are GenAI models? So GenAI models is a class of models that can generate new content. Yeah, so it's not like strictly designed for a single use case, but is rather able to generate many things. And here is an example. So here we have image generation model. So you put into it some text, some description, and it generates an image based on this description. But those models are not really limited to images. They can understand and generate text, videos, or even audio. And the most popular model family is large language models. And this is kind of AI models, generative AI models that can generate text. And it's very powerful because it allows you to accomplish many diverse tasks, and it has like some reasoning capabilities, so it can think about the task that it has to do, and therefore achieve high accuracy. And of course, LLMs works with text, but not only. You can also fit into the LLM, depending on the type of the LLM, you can fit into it also images, videos, or audio, and it can basically understand what's there and get some information from those data. Okay, so regarding the training itself, what are the difference between like generative AI and LLMs versus traditional AI? First, LLMs are trained on vast data and compute. So the top scoring models, state-of-the-art models nowadays, are basically trained on all public data available on the internet. So the data set is very huge. And the algorithm itself is also huge when it comes to number of parameters. Yeah, so there is a lot of basically of variables in such models, and therefore you need to have very big compute environment to be able to process all this data and show this data to the model and train it basically. So you put this data and this algorithm to your compute environment, and in a result, you are getting something called foundation model. So because you trained the model on such massive amount of data, and the model itself is such a big model, it can solve many different tasks without the need to retrain for specific use case. And example of those tasks can be, for example, classification, it can be translation, summarization, and many others, for example, code generation. The next thing I would like to talk about regarding LLMs is something called prompt engineering. And the base block is prompt. So prompt is basically the input you put to an LLM, and it can be as simple as a question you ask the LLM, and it uses it to generate a response, a relevant response to this prompt. And prompt engineering is an area where people are basically crafting instructions to solve very specific tasks. And the aim of prompt engineering is to achieve like good accuracy, good performance. And some simple examples are as follows. So it can be, as I said, a question, but it can be some more complex prompt. This is still very simple, but you can basically describe the problem that we want to solve with the LLM with a text. And here also two examples of in-context learning. So in-context learning is basically showing the model some examples that allows it to better follow the pattern that you want it to follow. And zero shot means that you do not include any examples for the model. So you ask it to do something, but it's up to the model how it will approach the problem. And with few shot learning, you can include some examples on how the problem should be solved, and therefore it should increase the accuracy and basically make the model perform better. So this is pretty often used technique when working with LLMs and prompt engineering. The next thing is variables. So you can add variables to your prompt. And here is an example. So you have some like boilerplate prompt with some instructions, but there are also those variables that you can that you can inject variables to during runtime, and it allows you to, for example, adjust the prompt to user preferences or to extend LLM knowledge. Yeah, so you can, for example, during runtime, get some external data and inject it into the prompt. Okay, so that's in regards to generative AI and LLMs as a quick introduction, and now retrieval augmented generation. And yeah, so why LLM only solutions are not enough in real world scenarios? First of all, LLMs are trained on basically historical data, some static data, and it might be insufficient for many real-world applications because they don't have access to real-time data like news or external data that wasn't public or isn't public. So the vendors are unable to basically download this data and train the model on it, right? And also, if you ask LLM something that it's not aware of, it can hallucinate, which means that it can make up some references, it can generate misleading information, and you don't want that. You want your solution to be accurate and written like real information. So how can we fix it? Few slides before, I told you that you can extend LLM knowledge using variables, and this is part of the solution. But in general, you want to use a retrieval augmented generation. And yeah, how it works. So I will use some simple diagram to showcase you what is the whole flow of such a solution, and how you prepare your application to use retrieval augmented generation approach. So first thing that you need to have is some data source. You need to have some data source with the data that you want to use in your application. So it can be like SharePoint, can be Google Drive, or anything else you can think of that you can connect to. And on the other side, you have your chatbot application. It's very high level and very basic diagram. So in a real world scenario, there would be much more to it, much more components. But let's keep it simple. So you have this data source and your chatbot app, and the first step is to download the data. Yes, so you download all the data that you want to have access to in your app. And yeah, and here is a simple example with one document. Yeah, so we work on one document example. So you have this document. It can be PDF, it can be some docx, or anything else that contains some text, or maybe images. As we can also work with images, as I said, LLMs understand them. And the next step that you need to perform is to transform this raw document to text, to plain text, so you can work with it further. And as I said, you can, for example, transfer image to text by describing what's on the image, and use it in your application. And the next step is splitting, and splitting or chunking. Let's use chunking. So you need to chunk your document, or split your document into smaller parts. And we need to do this because LLMs are something called, have this feature called context window. And context window basically specifies the amount of data that you can feed the model with. So you cannot put a very, very long document into the LLM because it will fail basically. So you need to split those documents into smaller parts called chunks, so we can work with it further. And the next step is creating an embedding. Embedding is basically vector representation of text. So you transfer it into this numerical representation, so you can then perform things like similarity search. We'll talk about it in a moment. So after you have your chunks and your embeddings, you can insert them into documents vector database and store them here, so you can then use them. So this is data ingestion part. And now how to utilize this database. So you have some user. The user sends a question to your chatbot app. And the question, similarly to how chunks are treated, is being embedded. So as question is text, you can embed it into a vector representation. And thanks to that, you can then perform similarity search. So you can basically compare your question or query vector with all the vectors in your document database. So compute some similarity scores, and therefore retrieve some similar chunks that are supposed to have some information allowing the LLM to answer user question. And this is basically the input to your AI model, to your LLM, which consists of a prompt with some variables allowing to inject this question and those text chunks. And based on this input, LLM generates some answer, but you then return to user. So here is the whole flow. And yeah, the anatomy of retrieval augmented generation is a first embedding model. So you need to have some embedding model to transform this text to numerical vectors. Embedding models are a type of AI models that specialize in generating such representations, right? So you can then use them to perform similarity searches. The next ingredient is vector database. So vector database is a special kind of database that allows to store encoded representation of your text, so those vectors, and allows you to perform those similarity searches. And the last ingredient is, of course, LLM that we use to generate the answer based on retrieved context from your database and, of course, user query. And regarding the prompt itself, it can look as follow. So we have some instructions for the LLM that you are helpful corporate assistant. Then we have some context. So context is basically documents that were retrieved from the database. And the last part is user question. And based on such input, the LLM generates the answer. Okay, so what retrieval augmented generation tries to solve? First, it allows you to access your company data or your private data if you build it for your own use case. It also enhances accuracy because you retrieve relevant and maybe real-time information to ground your responses in facts. It also reduces hallucinations. So because we use external sources, we can verify, or the LM can verify the content that it generates. It also improves performance in specialized domains, especially if we have some niche domains. We might be not able to, to help for our use case with LLM only approach, as it may be not aware of this domain. But if we have some external data, we can feed it into the LLM and it will help it to understand what we want. And the RAG also supports dynamic and evolving information. Yeah, so as I said, you can ensure up-to-date responses, even if the model was trained on some historical data. We can always update our database and go beyond the model training data. Okay. And some design decisions for RAG that you need to make when building such solutions. First one is chunking strategy. So the splitting of documents into smaller chunks. And there are a few approaches. First one is fixed size, and this is the most basic one, where you use some predetermined length. So you can, for example, specify how many words should you use for a single chunk, and the document will be then split based on this number of words in single chunk. The next one is recursive, where you use some hierarchical division. So let's say you have some PDF document that has some headings, maybe some paragraphs. So you can use those sections to divide the document into smaller parts, and this is more structure-aware splitting. And the last one I would like to talk about is semantic chunking, where you group your document based on its meaning, and you do it using embedding models. So embedding models, as I said, they generate a vector representation, and you can think of it like some semantic representation of the text. So then you can use it to group based on those semantics. Okay, the next thing is metadata filtering. So if you're able to gather some metadata for each document in your vector database, you can narrow the number of searchable documents thanks to something called metadata filtering. So it can be anything like location or language. So if you know what the document, what location the document refers to, you can add it to your database and use it as an attribute in your metadata. It can be department if the document refers to some department in your company, or it can be any other category. Date, for example, if you want to filter by date, or anything else you can think of. And example can be such questions. So what is the tax law in California? So let's say you have some chatbot that answer tax related questions, so it can filter documents that refers only to California tax law, and then narrow this number of searchable documents, and therefore you might improve your accuracy of your RAG pipeline. The next thing is hybrid search. And regarding hybrid search, it introduces basically two search pipelines. So instead of using only vector search and those embeddings during retrieval, you can use also keyword search. And keyword search is also called sparse vectors, where you concentrate on only matching documents that contains words or keywords that are present in user query. And of course, we still use semantic search, which we already know, which is called dense vectors. And then you apply some fusion algorithm. It can be anything like as simple as some average of both of them, of those similarities to create a single value. And yeah, and here is an example. So let's say you ask how to catch Alaskan pollock, and Alaskan pollock is a type of a fish. So dense vectors, semantic search, we will understand that catch means fishing in this context, and sparse vectors will match the exact term Alaskan pollock, and which will only return documents that contains this specific term. Yeah, and keyword matching may fail if we have multiple languages in our database, or the user question is asked in different language that the documents, because we are searching based on keywords. Okay, the next thing is ranking. So regarding the ranking, so Ranker is an AI model, and it focuses on calculating the relevance score between two input texts. So it returns a single value between 0 and 1, and the higher the value, the more relevant those two texts are to each other. And this allows you to get more accurate results than vector similarity-based methods. But because similarity-based methods are basically some simple heuristics that you apply on two vectors, right? And if you use ReRanker, it is trained for such purpose. So it will be much more accurate, but it is also more costly, because you need to compute this score for each document query pair. And if you use Ranker in your pipeline, you will have basically two-step retrieval process. So first step is to find potential candidates using search, hybrid or vector search that we already know. And then based on those potential or initial candidates, you run Ranker on top of them, creating pairs of query document as an input to the ranker. Okay, so that's it. And I want to note that the examples I talked about are only some examples, and there are much more to it. There are many other techniques that you can use depending on what is your use case and what you need in your pipeline, right? Okay, so next part is an overview of Amazon Bedrock. Yeah, so what is Amazon Bedrock? So first of all, it's a managed service in AWS, and it allows you to manage foundation models, so those AI models that you can use for diverse tasks. And there are many different models from leading AI companies like Anthropic and Claude, like from Meta. One example is Llama from Meta. Another one is, of course, Amazon, which has also quite rich variety of AI models, and other like Cohere and much more. And this service enables you to easy experiment with those models via something called playgrounds. So you can basically access those models right from the console and play with them and see how they score on your use case. It offers broad set of capabilities to build generative applications. You can create prompts in Bedrock and compare them between each other. You can iterate on them. You can evaluate your prompts or your RAG systems. You can also fine-tune models. Fine-tuning means that you are training your model on some small amount of data to perform better for some very specific use case. You can also build agentic workflows and do much more. This service is still evolving, so basically each week there is something new. And it also integrates well with services like SageMaker AI. So you can, for example, deploy some model or train some models through SageMaker Jumpstart, and then deploy it to Amazon Bedrock and integrate it in your RAG pipeline or agent and use it. You can use also services like AWS Lambda for some customization of your workflow, or Amazon S3, AWS S3 for storing some data. And of course, there is much more to it. Yeah, and regarding Amazon Bedrock knowledge bases, so one of the features of Amazon Bedrock, which we focus on today, first of all, is of course fully managed, so you don't need to worry about things like provisioning the models, managing the infrastructure of or your RAG backend. And it introduces end-to-end RAG workflow, which means that you can create your RAG and test your RAG assistants without the need to write a single line of code. And I will show it in a moment. It also contains built-in parsing and chunking strategies, and you can use some traditional methods to chunk or parse your documents, but you can also use LLMs to, for example, pass the document in a form of an image, and the LLM will parse the text from it. And then you can also use LLM to chunk, so split the document based on prompt that you provide for LLM. And you can, of course, also customize this parsing and chunking using Lambda functions. So if you decide that you want to use something custom that you developed, you can also use it. It also contains some built-in connectors. So you can, for example, connect to Confluence, Salesforce, or SharePoint, or you can use a web crawler. Those are, as of now, in preview, but you can test them, or you can you can upload your data to AWS S3, and it's also integrated as a data source that you can use for your RAG. You can, of course, also connect to some custom data sources. If you have some that are not supported, it's also possible. And the last thing is that it has a rich support for various types of databases. So the most popular is probably Amazon OpenSearch Serverless, but you can also connect to Amazon Aurora, MongoDB, to Redis Enterprise, or Amazon Kendra. Yeah, and now it's the time for the demo. We have a good timing. So let's now go to console. So here is the Amazon Bedrock. And as you can see, we have here different things. You can check what are the providers available. So as of now, we have Amazon, Anthropic, Coherent, Meta. We have something called Model Catalog, where you can basically filter the provider, or you can filter the modality that you want to work with. And as you can see, there's a lot of different types of AI models, and it's still evolving. Here are some playgrounds. So for example, you can select some model and ask it some question. What is the mass of the sun? And it will answer you. Of course, you can play with it with some more complex problems. This is just an example. And there is much more, but for now, let's focus on knowledge bases and how to create your first knowledge base. So in this view, knowledge bases, you have this button, create, and you can create knowledge bases with vector stores, which we talked about during this presentation. But from some time, knowledge bases also support structured data stores, which means that you can connect your knowledge base to some SQL-like database, and Amazon Bedrock will basically transform under the hood user question to SQL query. But for now, let's stick to vector stores. So here is the view where you're configuring your knowledge base. It has some name, so let's name it KB demo webinar everyone, because I already created one as a fallback. And then, yeah, some not very interesting things like AM permissions. Let's just create new role. And here we have data source details. So as you can see, we can select Amazon S3, crawler, custom data source, and those others. But for the needs of this demo, let's stick to Amazon S3, as it's the simplest one, and some other things that we do not need to configure. So let's click next. And here we will be configuring our data source. So let's give it a name, KB demo webinar 1. And when we need to provide a source location, so we need to provide a location where our data is placed. And maybe let me just quickly show you how the data actually looks like. So we have basically 3 files that are Amazon shareholder letters from like 3 years. And those are very simple documents, not much structure in them, but that's fine for our use case. Yeah, and we have actually 3 such documents, as you can see, about 10 pages each. It contains some data, and it's already placed in Amazon S3. So let me just quickly browse that, and it's here actually. So here we have those 3 documents. So let's click on it and let's choose this directory in S3. So here we are pointing to our data source location. And the next thing that we can configure is a parsing strategy. So as I said, we can use some let's say traditional parsers, which is called here as Amazon Bedrock default parser. But you can also select an LLM model that will basically process those images and probably generate more structured parsed documents. But as I shown you, our documents are pretty simple. So let's stick to Amazon Bedrock default parser for now. And we also need to specify chunking strategy. So here are some options. For now, let's use this fixed size chunking strategy, and let's specify max number of tokens. Let's use 512. Yeah, we can also specify transformation function. So as I told you, we can use our custom logic to chunk the document or to attach some additional metadata during processing. Yeah, so that's pretty much it when it comes to data sources and preparing the documents. And the last step is to create embedding model. So we will use Titan text embeddings v2 from Amazon. They are pretty nice. They are not very expensive, and they are pretty customizable. And we can specify here embedding type. So basically, floating or binary, depending on which one we use, we will get some better accuracy or we'll get some cheaper solution. Binary is cheaper, and as we have not much documents in our data source, let's use it. And also we specify vector dimension. Vector dimension basically specifies by how many numbers should be the input text encoded into vector. Yeah, so how many numbers in a vector you will have. And once more, as we have not much of data, let's use just the smaller one. And this also translates to how accurate your RAG pipeline will be. And also, the bigger the vector dimension, the more expensive is storing those vectors in your database. Regarding vector database, you can use quick create, so you don't need to configure your vector database, or you can choose a vector store you have created. As you can see, you have OpenSearch, Aurora, Redis Enterprise, Amazon Neptune, or Pinecone. But for now, let's also make it simple. So let's quick create a new vector store. And as you can see, we can only select OpenSearch serverless. That's because we specified binary vector embeddings, which are only supported by OpenSearch. Okay, so we're going through all these steps to configure our knowledge base, and it's now ready to be reviewed and eventually to create it. So let's now create knowledge base. And it will take up to a few minutes. So to not wait for it, let's just open knowledge bases in new card. And here is a knowledge base that I created like yesterday probably. So we don't need to wait. And here it is. It's ready to use. I would like to show you one more thing. So here is the details on our knowledge base, and we have also data sources. We can have multiple data sources for a single knowledge base. For now, the limit is 5. So let's click on this data source. And here you can see that we have some sync history. So we can manually trigger sync, and Bedrock will basically pull the data from our data source and process it and insert to our vector database. And we have some information regarding the number of source files and numbers of added files and things like that. And we can also check actual documents that we have in our data source. Yeah, so those are the ones that we added. Okay, and moving back to our knowledge base, we can test it right from the console. We don't need to, use some custom code to connect to AWS. And it's here actually. So we can select the model that we will use to generate the answer. So some LLM, and let's use Claude 3.5. And now let me copy the query that I prepared that is somehow relevant to our documents. So what is Amazon doing in the field of generative AI? Let's ask this question. And as you can see, the Bedrock is generating the answer, or rather LLM is generating the answer. And as you can see here, we have some references. Yeah. So actually, Bedrock provides this nice feature of citations, and it's good because it grounds the LLM answer in facts, because under the hood, basically, an LLM is asked to always provide those citations. So it also reduces hallucinations. And if we click on show details, here we have query configuration, so things like search type, and source chunks. So those are basically chunks that were retrieved from our vector database. Yeah, so here we have the content that was fed to the model, and the model used it to generate the answer. We also have some metadata that we can check, and as you can see, we have in this case 3 chunks. We can also configure it. For example, we can only use our knowledge base to retrieve data sources. Yeah, so this way, we won't use LLM to generate the answer, but rather knowledge base will return some documents. What we can also do is we can override search type. So we can use semantic search or hybrid search. Yeah, so semantic plus text search. It's also like out of the box supported in knowledge bases. And the last nice thing that I would like to quickly show you in this view is that you can apply filters. So I told you before that the one approach to designing RAG pipelines, RAG systems, is to use metadata filtering. And let me just quickly show you the example how it works. So I asked this question, what is Amazon doing in the field of generative AI? And it returned documents only with 2022 shareholder letter. Each chunk will have this 2022. This is because generative AI boom started this year. So if I now copy this, I have it actually pre-prepared. So let me copy it from my notes so I don't break anything. If I now apply a filter, and as I specify that I want my Amazon Bedrock knowledge base source URI to start with, this sign tells that it should start with some string, and let's change this 2022 that we have to 2021, and let's now apply this filter. And once more, let me ask this question. Okay, so look, those documents were from 2022, and now our documents are only from 2021, even though they probably don't contain any relevant information to answer this question. Yeah, so that's it regarding creating and using knowledge bases in the simplest form. You can also apply things like query modification. So you can, for example, instead of just passing the user query to the LLM, you can enable breaking down queries. So if you have some more complex question for the LLM, more complex task, you can break it into smaller steps, and therefore simplify the problem for the LLM. And it's also built in. You don't need to like develop it. It's available in knowledge bases. You can also use ranking. It's a very new feature of Amazon Bedrock. So you can select some model, some re-ranker model that is available in Amazon Bedrock, and also use it in your knowledge base on top of your search pipeline, which is also pretty nice. And now let's go back to this view. I would like to show you one more nice feature of Amazon Bedrock when it comes to knowledge bases, which is the fact that you can evaluate your knowledge base. So we need to specify which knowledge base we want to evaluate. Let's select this one and let's click evaluate. And here we specify evaluation configuration. So some KB demo eval webinar. We need to select evaluator model. So the model that will be used to compare our RAG pipeline results with our grant true from test data set. So let's select it. And actually, sorry for that, but let me show you how the data set itself looks like. So here is some basic data set that I generated using LLM. So it's probably not the best, but I just want to show you the structure of such data set. It's JSON lines, so each row is a separate example. And this structure is required by Amazon, by AWS. So yeah, we need to stick to it. But what it contains is basically response text that is our grant true that we want the LLM to generate. And we also have question for which this information should be generated, this answer. And this data set needs to be generated using with access to our source documents, yes, because to generate such answer, we basically need to have informations that are included in our documents. There are multiple ways of generating such data sets synthetically. You can also do it manually. But this is how it looks like. And we can use such data set to evaluate our pipeline. So now, as we selected our evaluator model, we also need to choose knowledge base, which is already selected. And one more thing, we can evaluate a retrieval only. So we can only evaluate whether for a given question, the documents that were retrieved are accurate. But we can also apply some more end-to-end evaluation, and we can evaluate whether the response of our knowledge base is valid, is accurate. So let's use this one because my dataset is prepared for this purpose. And as we want to evaluate responses, we also need to select some model to generate those responses as we did before. Yeah, we also need to specify some metrics, as you can see here. So let's just use correctness, faithfulness, helpfulness, and don't want to get in details into them for now. And now, sorry, we need to use our dataset first, okay? So our dataset is placed actually here, so let's choose it. And we also need to choose directory for our results. So let's choose this directory. And one more thing regarding metrics, I don't want to get into the details because there are a lot of them, and it all depends on your goals that you want to achieve with your pipeline and what do you want to optimize, right? But they are basically some values, some metrics that you can use to evaluate whether changes that you make to your system breaks the system or makes it better. Okay, and the last part is to provide some IAM role. So let's create a new one. And now let's create a new evaluation job. Something else, but no, it's fine. Okay, so it is in a creating state. So let's not wait. I also ran some evaluation job before, so we can now review it. So here is a finished evaluation job of our knowledge base. And when we proceed here, we can see some evaluation summary and job configuration report. And actually, we should see here also some results, but it doesn't show up now. So it's probably some bug. So unfortunately, I'm not sure if I will be able to show you this. Sorry. Okay, it's models. Wrong view. This one. Yeah, so actually here we have our evaluation summary. So all the configuration that we applied, things like evaluation model, generator model, some S3 paths, our knowledge base. And here we have our metric summary. So single value for each metric that tells us how good is our solution. The higher the value, the better for most of the metrics. For harmfulness, for example, the lower, the better. And here we can also look some more in details into each metrics and how it scores with our knowledge base. What are the results? And it allows you to quickly compare, for example, different configurations. Yeah, so this is all I wanted to say in regard to Amazon Bedrock knowledge bases. I hope I allowed you to understand it a little bit better. And now let's get back to our presentation. So yeah, so as you could see, it wasn't much of a work to build some simple RAG assistant. And now let's wrap up Amazon Bedrock knowledge bases. So so Amazon Bedrock knowledge bases allows you to build RAG without the need to write a single line of code. So as you could see, I didn't like program anything. I was just clicking through the console. And yeah, it supports for fetching data from external data sources. In our case, it was S3, so not really external because it's in AWS ecosystem. But setting up some SharePoint or Confluence connection is pretty easy. You just need to bring in some authorization configuration, and you're ready to go basically. Yeah, it supports many advanced ways to chunk data, and you can also chunk it using your own transformation lambda function. It integrates with a rich set of vector databases. As you could see, there were like 5 or 6 different databases that you could connect to. And yeah, and one nice thing that I very like is that you can evaluate right from the console, and it's really very reliable and tells you whether you are moving in the right direction. And the last part is some lessons learned. So yeah, those will be the more like the tips that we learned during the process of building such systems. And yeah, so what should you follow when building RAG? And the first and probably most important thing to consider is that quality of data matters. So garbage in, garbage out. Basically, if you put not really good data, not well-structured data into LLM or into your vector database, it won't perform good. So first of all, make sure that your data pooling mechanism works properly. This means basically that you want to make sure that you don't have any missing documents. So make sure that the data connectors supports all required file extension, file formats. Also make sure that all metadata is included, all metadata that can be useful when searching for the documents. It needs to be gathered in this stage, in first stage when you're pulling the data from the data source. The next thing is to make sure that your parsers are robust enough. So things like handling different types of files and being able to preserving the source document structure or handling images. Yeah, so if you want to allow the LLM to obtain some information from images, make sure to either transform them to text or somehow being able to feed the LLM with those images. And finally, make sure to deduplicate your data. Yeah, so if you have duplicated data in your data source, and you will put it into your vector database, it might happen that for some questions, the vector store will return the same chunks because we have multiple occurrences of some document. The next thing is to set up the evaluation pipeline. So you can do this by either using domain knowledge experts or using synthetic data sets approach, because vibes-based testing is not good. So do not rely on manual testing. It won't help you much, because you need to basically have some quantitative metrics that you can use to compare different experiments and iterate quickly. Yeah, so as I said, start with crafting a test dataset. And the next thing is to select critical metrics you want to optimize. So depending on depending on your KPIs, on your goals, there are multiple different metrics that you can use. Each focuses on something else. So you can use some subset of them to make sure that you are monitoring all the changes in your pipeline. Yeah, and therefore, as you have some evaluation pipeline prepared, and make sure that it's easy to use for your developers, this way you can quickly iterate and test your changes before deploying to production or staging environments, and letting test users know that something doesn't work as it should. Another thing is to set up user feedback mechanism. So this can be as simple as some, I don't know, Google Forms or some Excel file. And it's good to have some predefined structure so it's easier to analyze. And yeah, make it as simple as possible, because if it will be complex, the users won't use it. So include only things that are like very important from the perspective of evaluation and monitoring, and don't include some optional like fields in your feedback mechanism. And the structuring the feedback is important, because if it has some structure already, it should be easier to, for example, generate test data set out of it, because you actually for some scenarios you can use feedback from your users to construct such test data set, and it might be very useful. And place it somewhere or reference it somewhere inside your app, so the users can easily find it and use it. So they don't need to look for it in some external sources. Yeah, and general advice that when you start working on such systems, start simple. So do not try to use all those mechanisms that we talked about, like hybrid search, re-ranking, right from the very beginning, but rather try to build a baseline that you can iterate on then. And based on your feedback mechanism and your evaluation pipelines, try to analyze this feedback and understand where the system makes mistakes. And based on those, try to improve your system. Finally, don't overuse big models, and try to test smaller models that are also cheaper, right? Because you have smaller model that requires less computations, so it almost always will cost less. And that you can think of it as if you have some not as complex tasks to solve, you can try to use smaller models, like for chunking, or if you want to rewrite user query to make it more understandable for the LLM, you can try to use smaller models, and they may provide you very similar results, because they are really good with simple tasks, and sometimes even better than big models that tries to sometimes overthink what user ask for. Yeah, and this can be achieved especially with good prompting. So if you provide the model with good instructions, maybe some few-shot learning, so some examples, you can boost accuracy by a big factor, and it might be good enough to just use it. And once more, to compare those models between each other, you can simply evaluate your system on many of them, and probably also compare pricing options and make some trade-offs when selecting the best one. Okay, and that's it for today. So thank you very much. We are right on time. I hope this was helpful, at least a little for you to understand better how RAG can be created on AWS. If you have any questions, feel free to write an email or to visit our website. You can also access this QR code, which points to our website. So yeah, that's it for today, and thank you all. I can see that there is a lot of messages. Probably too much to review it now. So yeah, I think we can finish now.